So, what we're going to do now is talk about water for the city of DeKalb. And now that we've been introducing you guys all to the idea of glacial geology and everything like that, let's focus a little bit more on home, or your academic home, in this last section of this, and then we'll move on to soils. So this is just a geologic cross section along Lincoln Highway. So Route 38 runs through campus, and you guys should recognize that as the Home Student Center. There's the Convocation Center and stuff. And what this is with cross sections. So we have map views when we look down on something, cross sections when we cut across it, and then we can see the geology that goes down into there. So we can have here is the bedrock. That's right here. So this yellowish part here, it's part of the Platteville and the Galena, is the main geology in here. This is a weathered portion, or a limestone. So this is the upper bedrock. This is weathered. What does weathered mean? That means it was exposed to the atmosphere. It was exposed to the elements and stuff like that. And so it gets weathered and eaten up, and then it got buried. And so this is how we know this was subaerially exposed, or exposed at the surface. It was in here because this is a buried weather. It's up to 50 feet weathered. And then we have this Galena, the Galena Platteville, and stuff like that, and that is more intact rock. And then this right here, how it goes down and stuff like that, this is an old river valley that's in here that's been filled in. And what is it filled in with? What's filled in with the Glassford Formation, which is primary till. Outwash sands and gravels of what's called the Henry Formation is, we like to name these things, so and so when we're referring to something, say the Galena, wherever its extent is, everyone knows what that means. So we name rocks and formations, and then it's the same, wherever that formation is found, it's got the same properties, same name, same age, it's that same rock. Now, and then it's different because of the different geologies that happen in the area. So it's not like everywhere you go in the world you're going to find the Galena. It's only in certain parts of the world you'll find that rock. Just this little side note, during the Soviet era, they had this thing where they really wanted to have the same rocks across the entire country of Russia. Make it, the Soviet Union should have everything. And it didn't geologically make sense. So this is why you don't find dinosaurs everywhere, is that formation may have been raised, it may have been underwater. There's a lot of different reasons. Okay. And then the green here is the Wedren Formation. It's the Tiscowa-Till of the Wisconsin episode. So the Wisconsin episode should make sense to you now. The till, what that is. The Tiscowa is the name of the formation of the town. That's where the type was found. So that's a lot of times what these names come from, is where the type location is. And then we have with the Tiscowa-Till, like I said, there's about 100 feet of it right under here about campus. It's really boring. Great. This Tiscowa-Till, very low hydraulic conductivity, meaning it's great for not allowing water to pass through it. Really slow water to go through there, into that. And then it gets down into these buried valleys, which are sand and gravel, which, again, the sand and gravel is great for aquifers. So we have these nice aquifer materials that are inside of there. And so the little question marks means that we didn't have any records right here, so we can't connect these two together. We're not 100% sure, so we put question marks in. And we're not 100% sure about something. And then this is the Troy Valley Valley. So this is where we're getting most of our water from. So the Troy Valley, the Troy Bedrock Valley. So this is a major pre-glacial drainage way. So here is the city of DeKalb, and here's the city of Malta. And this is a diagram from 2004, which was showing what's an artist's rendition of what it would look like. Well, what this place would have looked like, and I'll show you some pictures in a few, is it looked like the Wisconsin Dells here between the city of DeKalb and the city of Malta. It would have been a big giant valley with these big steep walls with a river flowing through it, and then here's that tributary coming in. This would have looked like the Wisconsin Dells. So just imagine if the Wisconsin Dells got filled in. And we stripped off all that glacial till, we stripped away all that glacial material, and that's what would have been left in here. So starting, enters DeKalb County from the northwest, swings through DeKalb, and that's what this whole Troy Valley. I've shown you pictures of it. The local bedrock relief is about 300 feet, so it was really steep sides, so it's about 300 feet of drop down. So again, Wisconsin Dells. It's about 1 to 2 miles wide in here, and then it's a very flat bottom. So because there would have been rivers, and the rivers would have flown through it and filled it up. It cuts through the Galena Platteville dolomites, so that is a type of rock. Dolomite is a type of rock that's in the area. You can kind of see it outcropped a little bit if you drive on I-39 towards Rockford. There's some rocks over there near the Baxter Road exit where the landfill is. You can see this outcropping there. Oh, side note on that. That landfill in Rockford, south of Rockford, or by the airport off of Baxter Road, is probably one of the worst places to put a landfill. So first of all, the red bedrock, that weathered bedrock, is right at the surface, and then it's filled with sand and gravels, and they put a landfill on top of sand and gravels and a highly weathered bedrock. Hopefully you are starting to go, wait a second, sand and gravel is bad for landfill. Number 2, weathered rock. Lots of fractures, lots of holes in it. Horrible place to put landfill. Okay, sorry. Just a side note. And then they got filled in with Pleistocene sediments. So Pleistocene was the geologic time where we're when we think about the last glaciation. So it gets filled in during the glacial periods with tills. So that's it. Alluvial sands. So river sands. So that's alluvium, and sand and gravels. So that's what comes down into this in here. So this is what it really looks like. Yep, there's NIU. Yep, kind of boring, but if we strip off all that till, it's a gorgeous Marley Valley. But this is what it would look like. So Northern Isle without all the drift, or the till, that's what we call it. So the till is the other name for drift, and then this is that material that was inside of it. So when we look at it, they did a whole bunch of test wells, so you'll be looking at ill water in order to be able to look for some of these. And you can see the valley right in here. This is where the Troy Valley is. How did we find it? Well, we do all these well drilling. So we can't just strip off the till and find it. How do we find out about these things below the ground surface? I mean, legitimately, how did we know that there's this giant valley there? I mean, we can't see it. It's unseeable. We can't strip off the till. We don't have a time machine. So what do? We use things like ill water, we use test holes, we drill constantly, and then we take geology and we understand how geology works, and then we put together all of that geologic information and then be able to create these maps based upon all of these individual test holes. So when you look at the ill water map, you're going to find this. So, and you'll find some of these things and you'll look through them and you'll figure out how deep is it down to the bedrock. It's a very interesting point, is that you can create these maps. So this is how geologists do their work around here. If you're out west, where you can see the rocks, geologic mapping is usually done by looking at outcrops, and outcrops are the rocks that are on the sides of the roads or a mountain right there. But around here we have the subtle landscape, and so we have to use cores and the soil logs in order to be able to figure out the geology of the area. So the DeKalb water supply, it's Midwest bedrock. So it's in a Cambrian Ordovician aquifer. So those are the time periods in which the rocks were set down inside of there. That one has the radium problem I talked about, and it's overused regional aquifer because it's got a lot of water into it, so a lot of people use it. And then the Troy bedrock, a glacial aquifer system, has no radium, but it's underdeveloped. But it's only spatially limited, so we can't get to it everywhere. So the city of DeKalb, they went into the Troy Valley. They did a study back in the late 90s, and they put in 4 wells to see how much, and this GPM stands for gallons per minute, that they could pump out. And well number 15 can give us 1,100 gallons per minute that we can pump out of it. And well 15 is out on Nelson Road. It's out past the Convocation Center. And so, again, this is the bedrock surface contours. So each one of these lines tells us how deep it is down to the bedrock into there, and so we can find the deepest part of the valley. And so here is one of these little local things. So this is that main aquifer system that we were talking about. This Midwest bedrock aqua group was over in these areas, and then these Troy Valley, because it's only over here and it's way out west, then we have to bring the water in. Then we can figure out that this is probably a good area for us to get water out of. So we did some drilling. Here's the DeKalb wells. This is Tesno Nelson Road. This is what they found geologically into here. The speckled parts mean sand and gravel. The white parts are clay, and then when they hit bedrock at 400 feet, around 400 feet, a little less than 400 feet. And then these interbedded sands and gravels with clay is very typical for a glacier material that would come into here. So that's into that. And the relationship between the glacial and the bedrock aquifers, well, this is part of what we're trying to figure out was part of the question. I'm going to go back up here. When this project got started was, does this bedrock valley cut until the St. Peter sandstone? This St. Peter sandstone that's right in here, and you can see these are the wells. So here's well number 10. Here's wells number 1 and 2 that I just mentioned. The lines that go across this are where the screen is, so that's where the water is coming in. So you can see these really long screens. The St. Peter sandstone is that water. Remember we talked about the crosscuts, it outcrops out at Oregon and goes underneath the whole city. Great thing for water in here. And so you notice all these deep wells all go into it. The one at Nelson, well number 15, is getting water out of that sand and gravel. So that's where that water is coming in to feed the city of DeKalb. Well, the problem with this aquifer down in here is this is that Ensel St. Peter's, and it's a deep one, is, as we said inside of here, it's got the radium problem. So we don't want to use it as much. So we want to use more because this is that radium that's coming in from the deep bedrock and it's getting into these wells. So if we use well number 15, it doesn't have that radium problem inside of it. So one of the things that they wanted to know was, did this Troy Valley cut through and intersect the St. Peter sandstone? Because if it did intersect the St. Peter sandstone, then we know that whatever we do at the surface here can leak into this aquifer that is used by a lot of different areas. And so is this an area where there's recharge of this aquifer happening or not in this particular area? And so this is one of the questions that was set out with this research project to do. And so they went through there and they looked at to do some of the research projects. Here is what the Galena Platteville dolomite looks like. So it looks like a dolomite. It's limestones with some magnesium into it. If you are really bored and you want to learn about something new geologically, I'm not going to go into it in this class, but look up the dolomite problem. We actually don't have dolomite forming currently on the world, so how it was formed is actually really interesting. But you can see all the cracks and stuff like that inside of it. This is highly weathered and stuff, so you get these fractures, lots of water moves through. When it's really solid and competent, it doesn't allow as much water to come through. And so what they wanted to know was, is the city of DeKalb's well right here impacting the sandstone, and how deep and where does that water come in to that area? Because we've got this dipping bedrock here, and do we have this system right here? And so is this actually impacting it, and is there a relationship between these two? Because we have to understand this. If we want to know if we can grow the city and have more wells in here, we have to know where these things are located and how the water is working, because this impacts the whole regional area inside of here. And so they did some zone planning to say, okay, where is their low density population? We should have it because of getting water. So water was put into the city plan. Where can we grow? Where can we have enough water so that we're not mining our water? We're not going so far down that we are exploiting our system. And so they really looked at the hydrogeology of the area to make sure that when we're growing these new towns and stuff like that, growing the city, that we're growing it in a logical way in there. Okay. So with that, I'm going to stop for today, and you're going to have a homework assignment that's going to take up the rest of your time looking at this glacial material. So I'm going to give you a homework assignment. You're going to look at areas within inside of the Wisconsin, the Illinoisan, and the unglaciated areas of the state. I'm going to have you look for the wells that tell you how deep the bedrock is. And then I also want you to describe some of the things from some of the areas and list off the wells that you're going to get in there. And this will give you an idea of really embracing the idea that we're glaciated in the state of Illinois, and what can we be doing, and understanding the glacial history of it, understands where our water comes from. It also impacts what pollution can get into here. So if we have ag that goes on at the surface, can that atrazine, can that get inside of it? The next part of it, we're going to be focusing really at the surface. We're going to be focusing at that loess and the formation of soils, and talk about soils and wetlands and those near surface expressions, and how does that impact our local geology.